its thing out. There it goes. So in just the next second or so, there we go. It's all up and running, and so I'm going to be recording this just so that you know. I had somebody who was asking about making sure I did that for them today because they weren't going to be here. So I do have Ryan here with me. So my couple of just quick things. First of all, it was when I got back from my trip that all of the exams had come into me. So the last couple of days have been a little crazy. I'm going to get them done this weekend. By the time I go to bed on Sunday, I'll have all the exam grades, and I'll give you kind of a current average, because I'll have everything up there. I'll put all where we are with the web assign and all of that. So by the time I hit the hay on Sunday night, I'll have all of that, and then Monday I'll pop all of that stuff in the mail to you, so that you'll have it during sometime next week. So we'll do that. Monday and Wednesday we meet next week. I'm doing a little thinking. The next section after chain rule, remember I told you there's one section that's like the hardest section in the whole book? Now that's the section that comes up next. I may jump ahead and I may go and do something else, but I'm trying to decide. I want to look to see how exactly I'm going to say that material, and it's kind of like, okay, do I do it before break, or actually you're somewhat more alert and kind of into it, or do I do it after break when I have to wake your brains back up? And that's really the balance that I have. So do I want you to forget it over break, or do I want to put you through pain when you come back from break? And so there's kind of a decision I have to make. So what I want to do, though, today is I really want to spend some time, and I'm going to dig one more thing out here. I want to spend some time talking about the chain rule. So let's do a few more chain rule questions, and then we're going to kind of up the kind of level of difficulty here. So realize that's kind of where I'm going as well. Eventually, but we're going to start out by not being quite so difficult. So again, we're on chain rule revisited, section 3.4 revisited. So let's see what we recall. Suppose f at x is 6x plus 7 to the 8th power. And I want to take the derivative of that. First of all, how do I know that's a chain rule question? Exponent, that's going to be one thing, yep. Inside and outside, right? So, I'm going to do this out, again, I'm going to be somewhat painful for some of you. I'm going to do it out kind of the long way, and I'll do it out the short way. So if I were to do this out the long way, I determine my u, and remember u is the inside. So who's my u?
6x.
Yep. Then what did I do? What did I do immediately after I identified the u? Find the derivative. And what's the derivative of that? Yep. So that gives me kind of half of what I need. Then do you remember what I did after that? Yeah, I did kind of this outside, found my derivative of the outside. So what I did is I come back to this, and I actually rewrite the f at x, and it really officially becomes f at a u, where u is the 6x plus 7. That gives me that u to the 8th that I heard a couple of you say. So I'd say, okay, I have u to the 8th, and then just like I did before, I take the derivative again, and the derivative of u to the 8th is... Yep. And then once I do that, now I have this derivative. And that derivative, what did I do with those two? Multiply them. So I take u prime times f prime at u. And in this case, that's 6 times 8u to the 7th. Gives me 48u to the 7th. And then I'm almost done. I have one last step. What's that last step? Plug u back in. So final answer goes back to f prime at x, and that gives me 48 6x plus 7 to the 7th power. And there's my final answer. Now again, if we do it kind of the short way, and the way that, again, by the end of the semester, I'd love it if we could all be there. But I recognize, again, some of you are going to really kind of hop onto this. And that's completely acceptable. I'll show you why that's a little bit, why I encourage you to learn the short route when we look at a couple of other examples later on. Although sometimes the short route on the real complicated questions actually makes you keep your bookwork a little bit cleaner. But if I were going to do this, I'm going to rewrite the question. If I were going to do this the short way, what I do is I say to myself, I say, okay, how do I do it the short way? Well, I take the derivative of the outside, and remember that I need to keep the inside the same. And then I multiply by the derivative of the inside. So if I'm going to do it the short way, the derivative of the outside with the inside the same times the derivative of the inside. So the outside function is the 8th power. So how do I take the derivative of the 8th power? Well, it's 8 something to the 7th. And I said keep the inside the same. And so back in this set of parentheses, I put the 6x plus 7. And then I multiply by the derivative of the inside, which is 6. I'm going to tell you the biggest error that students make with these questions. They get so excited. They do such a wonderful job taking the derivative. You know, they do that, bring the 8 down, they do it, blah, blah, blah. They forget the little exponent on the final answer. They get so into bringing the number down, multiplying by the derivative on the final answer, they forget the exponent. That's the single biggest kind of silly mistake students will make. So, let's see what else we recall. What if I had f at x is, let's do this one, the cube root of 5 minus 6x, and I want to take the derivative. So, what do you think I do?
5 minus 6x,
Okay, so I need to work with the radical piece. So that's going to be my outside, isn't it? Yeah. Probably before I try to take any derivative, I probably need to rewrite it. So that's a power. What exponent goes with the cube root? Yep. Now if we do it the long way, what's the first thing I do if I do it the long way? Find u. What's my u?
5 minus 6x.
Yep. And then what do I do? Derivative of that. What's the derivative of that? Yep. Positive or negative? Negative. Negative 6. Yep. Then what? Do my f evaluated at u, and that's actually u to the 1/3, and then I find its derivative, which is what?
U to the negative 2/3.
Yep. And then what do I do? Yeah, I can actually plug in u. A lot of times students will do that. They'll say, can I plug in u right now? You bet you can. I mean, once we do that derivative, you can plug that in. Is this my answer? No, what do I have to do? Yeah, don't forget I have to multiply these two things together. So these two get multiplied. And so I'm going to have minus 6, negative 6, multiplied by 1/3, 5 minus 6x to the negative 2/3. Then we just have to watch our arithmetic, algebra, and sometimes that's what gives students, they try to even go further than you have to. What actually is happening is this is a number, I really can think of the 1/3 as in that setup, throw that parenthesis on so that matches. So I really could think of the 1/3 as a constant that's all being multiplied. And so those two together give me a negative 2, 5 minus 6x to the negative 2/3, which for my purposes is fine to call the derivative. Sometimes to check the answer in the back of the book, you have to realize that that's the same as negative 2 divided by 5 minus 6x to the 2/3, where you might want to take that exponential piece, the exponent part, and drop it to the denominator. And sometimes students, and sometimes books will do this. This last thing I do is certainly something I'll never necessarily expect you to do. But some people and some books will say, well, let me go back to the radical. We started with a radical, so let me go back to the radical. And so the index is 3 and the exponent's 2.
Would you want us to do those variables or the negative exponent?
I'm going to tell you, and Samantha, right?
Yeah.
Yeah, Samantha, I'm going to tell you, if you can get right to there, I won't be probably taking off any credit on a question of this level.
Okay.
Okay? It's just to match the answers in the book. Sometimes you have to do otherwise.
Okay.
Be careful as well when you do the WebAssign, and I put some WebAssign for, and I probably should mention that, I put some WebAssign on for next Friday. Next Friday at 11:59 p.m., which means my friends at Copenhagen, before you bug out of town, you want to do that WebAssign. So you might want to put that on the priority list to do. Any of the others of you who are going on spring break, you might want, it actually has the trig derivatives and then the chain rule questions. And so you'll want to make sure that you do that. You won't make me happy if you say, oh yeah, I left early, we left on Friday and I didn't get a chance to finish it. Forewarning, do it. Otherwise, you're going to get, I'll open it up for late, but you're only going to get 50% of whatever's left for you to do. So moving along. I want to show you another question, and then I'm going to go and do some of the E and sine and that type of thing. Suppose I have f at x is 3 over x squared plus 1. And you might say to yourself, well, silly math faculty member, silly, that's a quotient rule question. Well, I'm going to actually not do it as a quotient rule question. I'm going to show you how, if you want to avoid the quotient rule on a question like this, you can actually do that. So what I'm going to do is I'm going to think of the denominator as the entire denominator raised to the first power. And what I can then do is bring this up to the top. And when I bring it up to the top, it just raises the entire denominator to the negative first power. Notice you can't take and bring the x squared up and call it x to the negative 2. You just don't do that. You just have to put the entire denominator in parentheses and bring it all up and change the exponent outside of the parentheses. Nothing on the inside of what I have. Now, it becomes, I didn't do the other one, by the way, with the shortcut. I'll do this one with a shortcut. Now it becomes this charming question. I'll do this one kind of the both ways. Right? This 3, remember, is a constant. That constant's along for the ride. If you have a number times an expression, you don't need to use the product rule. You just carry the number out. So the answer is going to have this 3 roaming around. So when I go to get the final answer, I'm going to have f prime is 3 multiplied by something. And so I'm going to take the derivative of this piece. And so just like we did before, u becomes my inside. U prime is 2x. Then I'll realize that the function here, this is the same as u to the negative 1, right? This is my u. So I have u to the negative 1, and the derivative there is negative 1 oh, I sharpened a bunch of pencils. Why am I trying to use a clicky one that's not giving me lead? So now I'm going to take the derivative. It's going to be negative 1 u to the what power? Negative 2. You got it. Now let's stop here just for a second. Sometimes when students go to write this derivative, they will actually write this. Now, I on purpose put the little dot in there, but I put it quite lightly. Sometimes students forget the little dot, they misread what they write, and they suddenly think it's 3 minus. Be really careful when we're actually doing this. And I know I'm not quite to the problem yet, not quite to the answer yet. But, so be really careful. You'll notice the way I just wrote this, because I just wrote it down with the 3, that when you have a number like this and you go to write some of this in, be careful that you realize that you have multiplication and it's not subtraction. So in any event, there's my derivative of the outside. So again, this was the derivative of the out. This is the derivative of the in. And remember, I have to take those two and multiply them together. So I kept the 3 along. There's my derivative of my out. The derivative of the in is 2x. Put back in for u, and again, I could have done that up here. I'm just going to leave everything the way it is right now. So that would give me x squared plus 1, and then that's all to the negative 2 times 2x. And now I can do some multiplication of numbers. All right? Notice if I think about this, I have a whole lot of rearranging I can do. And if I wanted to do a whole lot of rearranging, I could have put that 2x part first, or closer to the first. And so I have this, which then it becomes fairly obvious that all of this gives me negative 6x, x squared plus 1 to the negative 2. Which again, I'm fine right here. You could stop right here. But in a book, they might say, okay, the negative 6x, let's keep that where it is. The item with the negative exponent, let's drop that to the bottom and give us a positive exponent. So now if I wanted to do the shortcut for this problem, the same problem, I'm going to rewrite it that way. Now if I wanted to do the shortcut, I say, okay, here's my outside, there's my inside, the 3's along for the ride, so I'll keep the 3 along for the ride. Derivative of the outside's the negative first power, so that derivative is negative 1 blah to the negative 2. And remember what was in the parentheses always stays in the parentheses. What happens in Vegas stays in Vegas. What happens inside stays inside. And then we need to remember, though, that we need to multiply by the derivative of the inside. And there's our 2x. And with a little bit of algebra, a little bit of rearranging the commutative property, we get back to the answer that we had previously. Notice, and I think this one's probably a pretty good illustration. Notice the work I did on the left side of the paper, and notice the work I did on the right side of the paper. Right? You burn a whole lot less pencil lead over here. But some of you, it's going to take a while to get there. So I'm going to flip the page unless somebody yells at me. So let's go to some of the other functions that we had. Let's see if we remember. Suppose I have y equals e to the 5x. And this one I'm not going to do the long version because I'd like us to get pretty quickly to not the long version. How do we take the derivative of e to a power? It's e raised to the same power, so it's e to the 5x. So to get the derivative, it's e to the whatever multiplied by the derivative of whatever, right? E to the box times the derivative of the box. Well, what's in the box? 5x. What's its derivative? 5. Which we would then typically write as 5e to the 5x. So, in short, on a problem just like this one, if you have y equals e to a constant times x, the derivative ends up being the constant times e to the kx. Really is, if you have just that, that's what it becomes. Now be careful. Sometimes I do this and I catch students. I'll say, what's the derivative of y equals e to the 6th? And I get all kinds of funky answers. But I don't usually get this one, which is the correct answer. Why is that the correct answer? E is a number. Right. E is a number. 6 is a number. This whole thing is a number. And the derivative of a number is 0. So be careful. You'll misread. You'll see an X when you shouldn't see an X. It's like the old trick that sometimes teachers pulled on you, where they'd give you something and there was a the. And you read right over the second the because your brain is seeing what it thinks it should see. Y equals e to the sine x. Anybody want to make a guess as to what the derivative of y equals e to the sine x is? Cos. Okay, here cos. Cos x, right? E to the sine x. Perfect. How did you get that? So, yeah, it's a little bit like that e to the kx idea, right? Remember, if we want to take, and I'm going to use funky notation that we're not as used to using. If I want to do the derivative, and that's what that d dx, that's another way of saying it, the derivative of what follows. If I want the derivative of e to the something, it's e to the something times the derivative of that something, or is the way you gave me the answer. You gave me the derivative of the exponent times e to the exponent, which works. And it's usually the way we would say it when we go to write the final answer anyway. And so it's e to the sine x, and then the derivative of sine x is cosine x. Beautiful. Wonderful. I'd like to take the derivative of y equals sine 6x. I'm going to do it out the long way. So bear with me. right? U is the inside, so U is, what's inside? Yep, 6x. Then we take U prime, and U prime is 6. Then we go to the inside, and so my y is going to be sine u, so I stick that in there. And I do y prime. So the derivative of sine u is cosine u. And then I just multiply these two together, u prime, y prime. 6 cosine u. So final answer, y prime, the final y prime, is 6 cosine 6x. Notice if I do it the shortcut, my shortcut version, remember my shortcut version was I take the derivative of the outside, inside the same, times the derivative of the inside. And so if I want to do it the shortcut way, derivative of the outside, keeping the inside the same. Outside, derivative of sine is cosine 6x, that's keeping the inside the same. And then the derivative of the inside is 6. There we go. Now, a lot of students start to realize again that, and this is true for any of the trig functions, that if y is sine such and such, y prime is cosine of the same thing times the derivative of the inside. If y is cosine of something, y prime, derivative of the outside. What's the derivative again of cosine? Negative sine. Inside the same. Derivative of the inside. Y is tangent of something. What's the derivative of tangent? Yeah, secant squared. So it'd be secant squared of the same thing times the derivative of the inside. I have 3 more lines. Let's do the other 3. Y is secant of something. What's the derivative of secant of something? I think it's this one, right? It's secant tangent, so it's secant blah, tangent blah. And then times the derivative of the inside. Now here's the question. Sort of like a trick question, a little like when John Kubis goes on the news at night with the weather question. See if we can figure out what the trick is or where the game plan is. I need to take the derivative of the inside. Which inside? Is it this inside, this inside, this inside? Do I need to take the derivative of the inside twice and put it on the answer? Do I only take the derivative of the inside once? What do you think? Once. It's this inside that I'm taking the derivative of. And I realize they're all the same item. But it's not, I don't take the derivative. It's not that I come back to here and take the derivative and the derivative. It's actually the derivative of that I'm doing each time. Y equals cotangent. What's the derivative of cotangent? You're close. Ryan said cosecant squared. You guys are starting to say that. Is it positive or negative? Negative. Remember, it's a co-function, so we have to take the derivative of cotangent is going to be negative. So it becomes negative cosecant squared of whatever. Becomes a derivative of whatever. And then lastly, derivative of cosecant whatever. What's the derivative of cosecant? Hearing a little bit of muttering, I hear Ryan. Negative cosecant whatever. Cotan whatever. And again, derivative of whatever. Think of where we've come in a couple of weeks. We've gone from long rule definitions to doing some stuff that's getting up there in the difficulty level. So let's shake it up a bit. I'd like to take the derivative of this. Y equals e to the 5x cosine 3x. So, what's going on here? What rule or rules am I going to need?
Product rule.
Ah, very good. Why the product rule? Yeah, because these two are multiplied. And you notice I on purpose didn't say multiplied by. I don't know if anybody noticed that. I said e to the 5x cosine 3x. But these two are multiplied. These are two different functions. This requires the product rule. And then within the product rule, I actually have to use the chain rule twice. Once for the e to the 5x and once for the cosine 3x. So I'm going to use my product rule so I figure out my f. What's my f, by the way? And what's my g? What's my f prime? Yeah, I'm hearing lots of this. 5e to the 5x. I go back to the rules that we had. This one is just a shade tricky. What's the derivative of cos 3x?
Negative sign.
Oh, yeah, negative sign. So, and be careful. You don't want to write 3 negative sine 3x. You don't want to write it that way because if you write it that way, you're going to think it's a minus. So you're going to want probably to either make sure you're clear that it's multiplication so you don't mess yourself up, or bring the negative way out in front. That's where sometimes folks do have the advantage if they say, okay, derivative of the outside cosine is negative sine 3x. So I kept the inside the same and then multiplied by the derivative of the inside. Sometimes people don't make that mistake as easily in that order on this particular question because then it doesn't look so much like subtraction and you're more inclined to put the negative, to have negative 3. But, you just have to get used to it and it all comes with practice. Okay, what's the formula for the product rule?
5g plus f g prime.
Beautiful, f prime g plus fg prime, and then we just plug in what we have. So 5e to the 5x cos 3x plus e to the 5x multiplied by, and I'm going to put parentheses just so I don't get subtraction appearance again. So it doesn't look like I'm subtracting those two factors. I'm going to write it that way. Now, this is another one of those cases where I generally factor out what's common. So what do both of those have? Yep. So e to the 5x, let's see, y prime equals, take out an e to the 5x. When I take e to the 5x out of the f prime g, that leaves me with Yep. And then here I'll have minus 3 sine 3x. Ta-da! Isn't that cool? Yeah, I'm the only one who thinks it's cool. Wanna ratchet it up a little bit harder? No, but you're probably going to anyway. Y equals, I'll let you chew on this one for a second. Y equals, in parentheses, 6x plus the quantity x squared plus 4 cubed, all raised to the 5th power. This right here is actually kind of a, you might almost call it a double chain rule. It's a repeated chain rule. And so, and I'm going to do this one out the long way because it might be a little bit more apparent to you when I go to do it the long way. And then I will crank it out the short way. So, if I were to do this out the long way, what I would do is I would first call this my u. So u is the big inside. And some of this might, for those of you who are kind of like buying into the shorter way of doing it, some of this might actually become clearer to you when I show you the short way. Right, so this is the big inside. Because really what's happening is here's my outside, then I move in a level to my next level, and then what's going to happen is I'm going to move into the next level. But so now what happens though is I think of this as the outside, and then everything else has to be the inside. Well, now I need to take the derivative of that. And I say to myself, oh, self, I know the derivative of 6x, that's 6. But now I need to take the derivative of this piece. Which if I'm doing it out the long way, I now have to back up a little bit and take its derivative. This is where it is helpful if, at least on a single level question, you can do the rule without having to do out all the work, because otherwise you're going to now have a new set of u's, which I probably wouldn't call u, I'd probably call v. I'd probably, if I go, oh, I need to take the derivative of this, so I'd probably be going down here and go, okay, let's see. I need to take the derivative of x squared plus 4 cubed, so let me go someplace else. And I go, okay, I'm going to call that v. So v is that inside. V prime is the derivative of that inside. Then what I'm going to have is v cubed. Using the old rule, I go back out to the outside, and its derivative is 3v squared. And so I need to take these two, and that mess gives me 6xv squared. And you're like, okay, now wait a minute, which letter do I don't need the v. I'm trying to make this sound really painful and confusing on purpose. I don't usually do that. But so I pull that down on the corner of the paper and I take its derivative. But that starts to get lost in the big problem. So this is a place where it's much easier to say, okay, if I see something that looks just like that, I can deal with something that looks that basic. And I can do the derivative of the outside. Right? Derivative of the outside gives me 3 blah squared, and I keep the inside the same, multiplied by the derivative of the inside. That's where if I can do some of the more elementary problems a little more quickly, when I go to take this derivative of the outside, keep the inside the same, derivative of the inside, which cleans up into that. this is the u prime. I need to go back, I still haven't dealt with this fifth power. So the outside, to do its derivative, is a u to the fifth. I take its derivative, 5u to the fourth, which is 5 times 6x plus x squared plus 4 cubed to the fourth. So I just put the u back in. And I'm still not done, because I now have to do u prime y prime. Make sure I wrote everything that we should. So 6 plus 6x, x squared plus 4 squared. That's my u prime. And my y prime is 5 times all of that in parentheses, blah, 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 6x plus blah, 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 to the third. Yep, all raised to the fourth power. This is one of those where after we've done all these other questions, you're like, there must be some sort of simplification I can do here. And the answer is no, not really. This is one of those where you're going to be compelled. I mean, there's a couple of things that you could. I mean, I happened to rig this so that on this one we could take out a 6 out of the first part. That 6 and that 5 could give you a 30, but this starts to get a little bit slimy doing that. This problem here that we just did, yeah, I might, in a homework or a tested setting, I might ask you one of those. This question here is really the question that divides the men from the boys and the women from the girls. I try to make sure that you can do the basic level ones, and this is the one that just pushes the limit. You know, you won't get 27 of these. It is the type of question, and there's some in the book, some that I'm going to be asking you to do that I put in homework that do get a little bit kind of in that direction. But you'll notice even your book doesn't do a whole lot with that. Yes.
So we can do the short rule if you do like
Yeah,
three rules in one.
Yeah, let's do that. Let me do that. I'm going to erase this for a second, and I'm just going to rewrite it because I think I can get the shortcut rule all in here. Let's do it that way. Okay. I'm going to do the shortcut rule, and it's a little like name that tune. I'm going to do this problem in 5 lines or less. That's all the paper I have. So, y prime. So now if I'm going to do the problem, the whole theory with these is I basically work from the basically work from the outside in. So if you're doing this and you have one of these that's a repeated chain rule, or any chain rule, you work from the outside in. So we take the derivative of the outside, keeping the inside the same. Here's the outside. That is the outside. So it's 5 whatever to the fourth, and I'm on purpose trying to make this line up. So there's my outside. This was my derivative of the outside. Now, and I am going to do this, I'm going to really squeeze because when I use that second line to do that. What I'm going to do, and I do recommend doing this instead of trying to do it all in one step, is now write out this. Write out either in words or just write this, which means the derivative of the inside. sometimes some of you will be able to do it perfectly in your head. Most of you probably, at least early on, need this intermediate step. So this was the derivative of the outside, and this is just saying, now take the derivative of the inside. The derivative of the outside that I already did, that just goes along for the ride. And now I'm going to take the derivative of the inside. Give myself as much room as I can. So derivative of the outside, keeping the inside the same, I'm going to multiply by the derivative of the inside. And so now I take the inside kind of piece by piece. Derivative of 6x is 6. Plus, now I have to take the derivative of this piece. I could, if I really wanted to really chew on it, and say plus the derivative of that piece. But I look at that and I'm like, okay, I recognize that piece. Its derivative is the derivative of its outside, 3, keeping the inside the same. Drop the power. Multiplied by the derivative of its inside, which is 2x. Notice, and this question done this way really becomes apparent of why we call it the chain rule. And this really is going, where did some goofy person come up with the chain rule? Well, we take the derivative of the outside, keep the inside the same. Then we move into the next chain, and the next chain is the inside. Take the derivative of its inside. Well, to do that, it's going to require running the chain rule again, and so I'm going to keep its outside and go to the inside. So we're kind of chaining a bunch of things together. Hence the use of the phrase chain rule. This right here, in all of the derivatives we do, this type of question, in all the different derivative rules, this is probably the hardest derivative rule process that we do. One of these where you end up having to do the chain rule a couple of times. If you get good at that one, you're probably going to be able to do almost any question I'm going to give you that's involving the chain rule. It's hard to get them a whole lot uglier than that. I want to show you one other. And actually, I'm going to show you two questions. I want to do the derivative of y equals sine of x squared. And I'd like to do this question. I'm going to call this A and this one B, just so that you know in your notes that you know you have two different problems. So I want to do the derivative of sine of x squared, and then I want to do the derivative of y equals sine squared x. They are not the same function. This one says square the x and take the sine. This one actually says find the sine and then square the results. These do not have the same derivative. So, A prime is not, in this problem, going to be the same as B prime. Yes? Was it the slide down thing? Okay, sorry. This one here's it. I'm going to call this one an easy question. So forgive me. I always hated when faculty members said something was easy. That's an easy question. That really is y prime is a derivative of the outside, cosine, keeping the inside the same, multiplied by the derivative of the inside. This one's really, right, the outside derivative and the inside derivative. This one, the final answer, is really 2x cos x squared. Right? That's the answer. This one, the second one, and I will tell you that this question here, maybe not exactly the same question, but something, you'll probably read my chicken scratch. This question right here, or something similar to it, it's a guaranteed test question. Guaranteed. The secret to the success here is to not think of this question this way. It is to think of it as y equals sine x all squared, what it's equivalent to. That square is the same as sine x times sine x, or sine x all squared. And if you're just like, oh, I could call it sine x, I'll do the product rule. Have fun with that, because I'll probably give you something like sine x to the 11th power. I'll give you sine to the 11th x. Have fun with the product rule. So this is the secret to this one, because now it becomes a fairly obvious chain rule question. Derivative of the outside is the 2, drop the power to 1. Keep the inside the same. So there's my derivative of my outside. And there's my derivative of the outside. And then what I have to do is multiply by cos. Yep, don't forget the of x. I know that that's what you mean. The derivative of the inside. I will warn you, when this question comes up in the book, in the book, they'll sometimes freak you out because they will write this as the final answer, and you're going, where the bleep did that come from? Well, this right here, if they do this in the book, that's an old double angle formula from high school trig or pre-calculus. All they're doing is just rewriting it using one of those formulas from last semester. I don't care. I don't care when they do the double angle formula. Just realize sometimes they'll do some weird stuff like that. Okay? Well, what do you think? At 8:55, should we quit? I think so. Have a great, great day. And again, I put some web assignment. I put a book assignment, and a little later today there'll actually be the next collected assignment appearing. So be looking for that sometime before the time you go to bed tonight. Have a wonderful weekend.
Hey guys, I just sent this out to everyone texting about the
Have a nice weekend, Ryan.